So in this video presentation, we're looking at pairs of similar triangles. And in that, so we're trying to find missing sides of these triangles. Now, whenever we have similar triangles, what happens is that this is caused by dilation. Therefore, we would have corresponding sides. All right, so we'd have corresponding sides. So the fact that we're told that they are similar, what we're going to do is to find the sides that do correspond. For example, this side correspond with this side, right? X correspond with 15, the Y correspond with the 12. So in other words then, because they're similar, there is some number that can change the 3 to 9. That same number will change X to 15. That same number will change Y to 12. But a way in which we can solve this systematically is that we could set up this using proportional equation, where we're going to identify a pair of known corresponding sides. And from that, we're going to use it to solve problems. So let us say that I decided that the sides from this triangle, I'm going to put at the top of my fraction, and the sides from this one, I'm going to put at the bottom. Now, remember, I could switch them around if I want, but I just have to be consistent. For example, 3 over 9 is equal to X over 15. So what am I referring to? I'm referring to the fact that from this triangle here, I'm going to put the sides at the top, and from this one, I put the sides at the bottom. But I'm making sure that I'm using pairs of corresponding sides. So in an effort to solve this, all I have to do at this time is to cross multiply. So 9 times X will be equal to 15 times 3. So let us do that. So 9 times X will give me 9X, and this is going to equal to 3 times 15. So basically 9X is now equal to 45. In an effort to find X, I'm going to divide both sides by 9. And so I'm getting X equal to 5. So there it is that I've solved, and I've found X equal to 5 here. So the next move is to find a value for Y. I can still approach this by using the two known corresponding sides that I have, or I could use the new pair, because here I have 5, which correspond with 15. So I feel like I want to use 5 and 15. All right, just to switch things up. So again, the sides from the first triangle here, I'm going to put at the top. So I'm going to have 5 over 15, which is its corresponding sides. And I'm going to let that equal to Y over 12. So as you could see, I link my pair of corresponding sides, but the sides from this triangle will go on top. At this moment, I'm going to cross multiply. So I'm going to have 15 times the Y, and it's going to equal to 5 times 12. Let's set that up. 15 times Y will give me 15Y. And that is going to equal to 5 times 12. 15Y is equal to 60. So if I divide both sides by 15, then I could say Y is equal to 15 into 60 is 4. So Y is equal to 4. So here it is that I have found those values here. Let's take a look at another problem. So this is a similar case, right? These two triangles are similar. So there are corresponding sides that are in proportion. We could identify the sides that are corresponding. For example, Y correspond with 6.6. The 3.5 correspond with 10.5. The X correspond with 12.6. So having seen those corresponding sides, I'm looking for a pair of corresponding sides that I have the value for. And here it is. I have 3.5, 10.5. it's up to me to decide which one go at the top. So I'm going to say, you know what? I'm going to put these at the top from this triangle, and I'm going to put these at the bottom. There is no requirement to put them there at the moment. We're just saying here that because the sides are corresponding, we can decide from which triangle we want to put those at the top. So I decided. So in this case, I can say 10.5 over 3.5. So these are the known sides that I have, and they correspond. And it's going to equal to 12.6 over x. I am now linking 12.6 with x because these are two corresponding sides, and I'm in search of x. We're going to cross multiply because we're looking at a proportional equation. So 10.5 times x give me 10.5x. This is going to equal to 3.5 times 12.6. Now let's rewrite this. 10.5 x is equal to, let's see what 3.5 times 12.6 give. It gives 44.1. In an effort to find x, I'm going to divide both sides by 5. So on the left side, I have x. So I'm going to divide 44.1 by 10.5, and it gives me 4.2. So it means then that the value for x is 4.2. All right, let's take a look at the other problem. We're in search of y. Y correspond with 6.6. So I can set up my system the same way. So in setting up my system, all I have to do here is that I'm going to put my known corresponding sides as a fraction again, which is 10.5. I'm going to put it over 3.5. It is equal to 6.6 over y. These ratios are equal, so I can solve here. So now I'm going to cross multiply. 3.5 times 6.6 is equal to 10.5 times y. So let's write it down. 10.5 times y is 10.5y, and 3.56 will be multiplied by 6.6. So 3.5 is multiplied by 6.6. Let's see what we have. 10.5y is equal to 23.1. Let's divide both sides by 10.5 so that we can find a value for y. So y is going to equal to 2.2. So the value of y is 2.2. Let's look at the last problem, the problem here. So what we want to do is to make sure that we're identifying the sides that are actually corresponding. For example, this 5 here correspond with the 15. So when we observe the shape, look where the angle is, we're seeing that the 5 correspond with the 16, the 10 will correspond with the A, and the B correspond with the 9. So that is how we see the sides that are corresponding. But remember that we need to set up a ratio, or what we call a fraction, of the corresponding sides that we have values for. So we only have the values for that pair, 5 and 15. So we could set them up as a ratio. So I could decide what I'm going to put at the top. It doesn't matter. Just make sure that we're consistent. So I'm going to put the top diagram at the top. So that means I'm going to put 5 on top of 15. And that is going to equal to 10 on top of the A. Remember, if I've decided that this diagram, I'm going to use the sides on top, I'm going to use it all the time. Likewise, if I'm going to decide that this diagram, I'm going to use the sides at the bottom, I'm going to use it all the time. Remember that these pairs, these fractions that we're using, they must be from corresponding sides. So let us work this out. 15 times 10 is equal to 5 times 8. So we are cross multiplying. When you multiply 5 times 8, you do get 5a. When you multiply 15 times 10, you will get 150. In search of a, I'm going to have to divide both sides by 5. So a is equal to 30. So here it is. I've found the value for a. So let us go and find the value for b. I can still use 5 at the top over 15 because I still have that as a known pair of corresponding sides. So remember, b is from my top diagram. So I'm going to have b at the top over 9, which is from my bottom diagram. So from this, I'm going to cross multiply again, where 15 times b is equal to 9 times 5. Let's write it down. 15b is equal to 9 times 5. So 15b is equal to 45. Let's divide both sides by 15. And then we'll have b is equal to 15 into 45 goes 3 times 3. So that's my second response. I hope you understand what we just did on similar triangles. See you next time.